Alright, in this lesson, we're going to look at quadratic functions in turning point form. We have looked at quadratic functions in general form and also in root forms. So now we are looking at the turning point form. So by the end of the lesson, you should understand the turning point form of a quadratic function. You must be able to describe how a parabola can be transformed based on the turning point form. And you must be able to determine the axis of symmetry, turning point, whether it's a maximum or minimum, x and y intercept. You should be able to use completing the square to transform the general form to turning point form and be able to determine the domain and range of a quadratic function in the turning point form. So you also need to know how to sketch it. So here, just to remind you, the key feature of a quadratic function, the shape, the concavity, which is plus implies concave up, minus implies concave down, or what I call the U shape, and the N shape. Alright, and then you need to know the x-axis intercepts, the y-axis intercept, the turning point, whether it's maximum or minimum, and of course the axis of symmetry. Now, let's have a look at general form to turning point form. This is the general form, and you know things like axis of symmetry, turning point, and intercepts associated with that. You know how to find this. Now for the turning point form, you can write it as y equals a in the bracket x plus p square plus q, or a in the bracket x minus p all square minus q, and so on and so forth. Alright, so what we need to look at is how to determine the axis of symmetry and how to determine the turning point. This is called the turning point form because from the turning point form, it is a lot easier to determine the axis of symmetry and the turning point. Alright, the intercepts are still the same. Y-axis intercept occurs when x equals to 0, and x-axis intercept occur when y equals to 0. And remember, there may be no x-intercept. Alright, now, I want you to use your class pad. Let's have a look at the situation of the general turning point form when a equals to 1, which is the monic quadratic equation. Just remember, a is actually just a dilation factor, whether you make the parabola larger or smaller. Alright, let's get your class pad out and use your class pad. Plot this. Plot y equals to x square, y equals to x plus 3 all square, and y equals to x minus 3 all square. Once you've done it, just check with my video. Alright, with the plus 3 all square and x minus 3 all square, you can see that the parabola is moved left or right by 3 units. So here, when it is plus 3, it actually moves to the left by 3 units. Whereas when it is minus 3, it moves to the right by 3 units. Alright, so this is actually not intuitive. Plus doesn't mean that you're moving it to the right. You actually plus, you move it to the left. Okay, now next one. Again, once I've reviewed the equation, just pause it for a while. The next one, you need to plot x squared plus 2 and x squared minus 2. Alright, now once you've done it, unpause the video and let's have a look at your results. This is what I get. You can see that when it is plus 2, I have moved the basic parabola up by 2 units. And minus 2 means it moved down by 2 units. Alright, so now I'm combining everything together. Let's do the next. X plus 3 squared plus 2 and x minus 3 square minus 2. Again, pause the video for a while. Now check your answer against mine. You can see that for the first one, it has moved across left by 3 units and moves up by 2 units. And for minus 3, it moves to your right by 3 units and moves down by 2 units. Alright, so therefore we can say that the basic parabola is being translated up or down and left or right. Now, this is the effect of adding or subtracting a constant. So this is actually a vertical translation when we add or subtract a constant. So if q is less than 0 in this case, the basic parabola is translated under the x-axis by q unit. If not, if q is greater than 0, the y equals x squared parabola is translated above the x-axis by q unit, and the turning point is 0q. Now, this time we are looking at the effect of adding and subtracting a constant to x and then square. Y equals x plus p square and y equals x minus p square. So we can see that x is equal to minus p for x plus p square, and x is equal to plus p for x minus p square. Alright, so this is actually important. Now, for the horizontal translation, x plus p, you move across to the y-axis by p unit. X minus p, you move across to the right by p units. And the turning point, the vertex, is plus p 0 or minus p 0. Now what if I combine both? You can see that for the purple line y equal x squared, when I draw x plus p square minus q, it moves the red, the purple parabola to the left by p units and move it down by q units. Let's first look at the effect of adding or subtracting a constant to y equals to x squared. In this case, this is actually the vertical translation of y equals to x squared, the basic parabola. Axis of symmetry is still the y-axis, or x equals to 0. Alright, and then if q is less than 0, the basic parabola is translated under the x-axis by q unit. In other words, it's moved down. If x is greater than O, the basic parabola is translated above the x-axis by q unit. In other words, it's moved upwards. So let's put an arrow, move downwards and move upwards. Alright, so now the turning point for the vertex is either 0 plus q or 0 minus q. It depends on where it is. The effect of adding and subtracting a constant to x and then square is actually the horizontal translation of y equals to x squared. This time, the axis of symmetry, if x is p is added to x and all square, the axis of symmetry is x equals to minus p. If the p is taken away from x, the axis of symmetry for x is actually plus p. So for x plus p squared, the basic parabola is translated to the left of the y-axis by p unit. For x minus p all square, the basic parabola is translated to the right of the y-axis by p unit. And therefore, you can see that the turning point is plus p 0 or minus p 0. Alright, let's have a look at the graph. This is a general graph. Purple line is y equals to x squared. Red line is y equals to x plus p all square minus q. So you can see that the translation of the basic parabola from y equals to x squared is actually move to the left by p and then move down by q. The black line, y equals x plus p squared plus q. It moves across by p and move up by q. Alright? So you can see that x plus something is moved across to the left. Next one, again I'm using the purple line, y equals to x squared, the basic parabola. Now, if I plot y equals to x minus p all square minus q, you know that the parabola is moved across to the right by p units and then move downwards. For the black parabola, x minus p all square plus q, again move the basic parabola to the right by p unit and move up by q. So when y equals x plus or minus p square plus or minus q, these both vertical and horizontal translations will occur. Basically, it's a translation of y equals to x squared, and q is the vertical translation, while p is the horizontal translation. The axis of symmetry is then x equals to minus p or plus p, and the turning point will be minus pq or pq or p minus q or minus p minus q. Alright? Now, what if I add a? Remember, a is just a dilation of a dilation factor of y equals x plus or minus p squared plus or minus q. Alright? Basically, y equals to a x plus or minus p squared plus or minus q has the same shape as y equals to ax. So again, you should notice these are actually the effect of a. Now, this slide is basically the same as the previous two slides ago, except we've got the dilation factor a in front. And here, I'm not going to go read through the whole lot. Pause the video for a while and go through that. Alright? The effect of a is basically making the parabola narrower or wider. And if it's negative, it reflects the parabola about the x-axis. Alright. So, a summary of when y equals to minus a, x plus or minus p squared plus or minus q. So this is a reflection, like I say. And in this case, we will have a maximum turning point, no longer a minimum turning point. The rest is all the same. P and Q, the movement is basically exactly what I described before. So I'm not going to go further into that. Here, if you know what the red line is y equals to x squared, can you give me the equation of A, B, and C? Pause the video for a while. Think about what I've said about the turning point form, and you should be able to write out the equation using the turning point form. Now, you know that curve A. This is y equals to x squared translated to the right by 3 units and up by 1 unit. Therefore, the equation is y equals to x minus 3 all squared plus 1. Remember, x minus 3 means it moves across to the right by 3 units. Plus 1, move out by 1 unit. Sometimes you may be asked to describe the transformation. You have to be able to describe it. Part B is actually the basic parabola reflected along the x-axis. Therefore, the equation is y equals to minus x squared. And finally, part C. You know that curve number C is minus x squared translated to the left by 2 units and up by 6 units. And therefore, the equation is y equals to minus, I typed this incorrectly, minus x plus 2 all square plus 6. Alright, remember there is a minus there. going to enlarge that so that you can see it. Alright, let's move on to the next slide. So, when we've got a general form to the turning point form, you can work out the axis of symmetry by basically, if x is plus p, the axis of symmetry is x equals to minus p. When you've got x minus p, the axis of symmetry is x plus p. And you can work out the turning point. The key features of y equals to 2 into x minus 2 all square minus 5. First, the shape. It is actually a concave up parabola, which is the U shape. Okay, because that's positive a. And then we know the axis of symmetry is actually x equals to plus 2. And the turning point is actually 2 minus 5. Alright, from the equation. And you know that this is a minimum since it is a concave up shape. And then to determine the y-intercept, when x equals to 0, y therefore equals to 2, 0 minus 2 square minus 5, which is 2 minus 2 square is 4 minus 5, which minus 5, which means is 8 minus 5, which is 3. Alright, so then we can determine the x-intercept. This is when y equals 0. So 2x minus 2 all square minus 5 equals to 0. 2x minus 2 square equals to 5. X minus 2 all square equals to 5 over 2. And therefore x minus 2 equals to plus or minus square root of 5 over 2. And x equals to 2 plus or minus square root of 5 over 2. Alright, now that we have all the key features, we can actually sketch the parabola. Again, remember, I always say use a ruler. Y-axis and x-axis. Alright, you know that the axis of symmetry is x equals to 2. So that's somewhere around here. So x equals to 2. Turning point is 2 minus 5 minimum. So let's call it this point. 2 minus 5. And you know that the y-intercept is this point here. Let's say here. Alright. 0, 3. And then you know that the x-intercept is somewhere here and somewhere here. So we can actually sketch the parabola. And remember, label it y equals to 2x minus 2 all square minus 5. And label the x intercept as well. 2 plus square root of 2, 5 over 2, 0. And this point here is 2 minus square root of 5 over 2, 0. That is all you need when you sketch a parabola. No skill needed, and you should be able to show the correct shape, the y-intercept, the x-intercept, the turning point, and the axis of symmetry. Let's look at this quadratic equation. I want you to pause the video for a while and actually work on this. Think about all the key features and then sketch the parabola. You can use your class pad to confirm that what you sketch is correct, or you can check your answer with mine. Now, let's start with the shape. Okay, so this is concave down and is the shape like this, what I call the N shape. So we know that the axis of symmetry or line of symmetry is actually x equals to plus 3, and the turning point, this time is maximum, is 3 and 5. So let's look at the y-intercept. That is when x equals to 0. So substituting x equals to 0 in equals to minus x minus 3, 0 minus 3 square plus 5. Alright, 0 minus 3 is minus 3, minus 3 square is 9. And there's a minus here, minus 9 plus 5 equals to minus 4. So the y-intercept is 0 minus 4. Now for the x-intercept, this is when y equals to 0. So now let's have a look. 0 equals to minus x minus 3 all square plus 5. And we can actually move minus x minus 3 all square to the left hand side, and it will become x minus 3 because I added the x minus 3 all square here equals to 5. So x minus 3 equals to plus or minus square root of 5, and x therefore equals to 3 plus or minus square root of 5. And we can write it in the coordinate format: 3 minus square root of 5, 0, and 3 plus square root of 5, 0. You do not need to give a decimal answer unless you are asked to do so. Alright, and we are sketching only. We don't really need to know the exact position. Right, use a ruler, y, x. Now we know the axis of symmetry is plus 3, so let's estimate it to be here. X equals to 3, and then the turning point maximum is here, 3 and 5. And now we know the y-intercept is 0 minus 4, and let's sketch the graph first before we label in the x-intercept. Alright, so this point will be 3 minus square root of 5, 0, and this point will be 3 plus square root of 5, 0. Now I know that this is greater than 0 because square root of 5 is between 2 and 3, so it's actually greater than 0. 3 minus something which is less than 3 is actually greater than 0. So this is how you should draw it, and of course label it: y equals to minus x minus 3 square plus 5. Alright, now let's do this. Determine the key features of y equals to x squared minus 6 plus 1. I want you to turn x squared minus 6 plus 1 into the turning point form. How do you do that? You actually do so by completing the square. Pause the video for a while, do the completing of the square of factorization, and square for this. Let's have a look. Y equals to x squared minus 6x. You know we need to add 6 over 2 square minus 6 over 2 square plus 1. The procedure of completing the square. Therefore, we know that it's x squared minus 6x plus 9 minus 9 plus 1, which means this is x minus 3 all square minus 8. See, this is the turning point form. So you know that the shape is concave up because it is positive. And then you actually know that the axis of symmetry is x equals to 3, and the turning point, in this case is minimum, is 3 and minus 8. You don't actually have to calculate the y-intercept because it's given here. So the y-intercept when x equals to 0 is 0 and 1. And we can use the factorized form to work out the x-intercept. When x equals to 0, y equals to 0 actually. So x minus 3 square minus 8 equals to 0. X minus 3 all square equals to 8. X minus 3 equals to plus or minus square root of 8, which is plus or minus 2 square root of 2, and x therefore is 3 plus or minus 2 square root of 2. So again, when we actually write the coordinate, is 3 minus 2 square root of 2, 0, and 3 plus 2 square root of 2, 0. Alright, we can now sketch the parabola. Y, x. We know that the axis of symmetry is x equals to 3. X equals to 3, and the turning point is 3 minus 8. The y-intercept is 0, 1. And let's sketch the curve before we actually draw in the x-axis. That's a little trick that I always use, because it's only a sketch, it's not exact. So therefore this point is 3 minus 2 square root of 2, 0, and this point is 3 plus 2 square root of 2, 0, and label y equals to x squared minus 6x plus 1. Alright, pause the video for a while and try do this question. Here, you need to complete the square for sure. And there's one more step before you complete the square, which is take out the minus 1. Try it and then check your answer with mine. Pause the video for a while. We know that y equals to minus, put a bracket, x squared minus 7x plus 2, taking the negative 1 out. Therefore, factorizing by completing the square, this is x squared minus 7x plus 7 over 2 all square minus 7 over 2 all square plus 2. Alright, so that equals to minus x minus 7 over 2 all square minus 49 over 4 plus 2 equals to minus x minus 7 over 2 all square plus 49 over 4 minus 2. Multiply the minus in, and therefore I've got minus x minus 7 over 2 all square plus 4. 49 minus 8 is 41. Alright, now we can start off with the shape concave down because of the minus, so that is N shape. That's what I call M shape. It's not widely used, alright? So we know that the axis of symmetry is actually x equals to 7 over 2, which is about 3.5, but I'll leave it at 7 over 2. And then the turning point in this case is maximum is actually 7 over 2, 41 over 4. Alright, now we know that the y-intercept is 0 minus 2, straight from this equation. And then let's calculate x-intercept. When y equals to 0, x minus 7 over 2 all squared is plus 41 over 4. Alright, so rearranging, we've got x minus 7 over 2 all squared equals to 41 over 4, which means x minus 7 over 2 is the same as plus or minus square root of 41 over 4, and x is therefore 7 over 2 plus or minus square root of 41 over 2. And you can actually write it this way: 7 minus square root of 41 over 2, 0, and 7 plus square root of 41 over 2, 0 as the x-intercept. Now, very quickly sketching it, and I've got limited space here. Again, remember I use the word sketch, so it's not to scale. Alright, you know that the axis of symmetry is 7 over 2, so let's say somewhere here, and y-intercept is somewhere here. Alright, this is the axis of symmetry, and y-intercept is here, 0 minus 2. And this is x equals to 7 over 2, and this point here would be, let's call it the turning point, 7 over 2, 41 over 4. Alright, let's draw it. Sketch it, actually not draw it. Okay, and then label these 2 points. Of course, the y-intercept as well. 0 minus 2. This point here, it's then 7 minus square root of 41 over 2, 0. And this point here is 7 plus square root of 41 over 2, 0. And of course label it y equals to minus x squared plus 7x minus 2. Alright, so that's what you can do. Now, we need to determine the domain and range of a quadratic function based on the turning point form. So now, for the function fx equals to x minus 3 all square minus 8, we know that, or we are given, the domain of x is such that x is in the element of real numbers. And from the turning point form, we know that this function is the turning point of this function is 3 minus 8, and this is a minimum. You know the shape is a U shape. And because this is the minimum, let's sketch it quickly. This is minus 8. Alright? 3 minus 8. Therefore, the range of fx is above that, minus 8. So the range is therefore fx is a member of element of the real number, and fx is greater or equals to minus 8. Alright, now let's have a look at this function. You know that it is a concave down shape because of that negative, and therefore the turning point is actually a maximum, and it should be minus 4, minus 3. Right? So now, let's see. When the function is minus 2, which is the lower limit of the domain, this is actually my x minus 2 plus 4 all square minus 3, which is minus, this is 4 minus 3, which is minus 7. And when the function is f5, we'll have minus 5 plus 4 all square minus 3, which is minus 81 minus 3 equals to minus 84. Now here, doing a quick sketch, you know that this is a maximum. Alright, this time the maximum point is minus 4 minus 3, which is here. It's actually telling me that there's no x-intercept. This parabola here has no x-intercept. So now we know that here this is minus 4. However, the domain specified that we are from minus 2 to 5. Okay, so therefore we know that that maximum is not the turning point. The maximum is actually minus 7 and the minimum is minus 84. Alright, so therefore the range of f of x is actually fx is such that fx is an element of the real number and it is between minus 84 and minus 7. Alright, this is actually a tricky one. Normally we do include the maximum or minimum, but the domain this time restricted us. Let's have a look at the next one. What about this one? For the function fx equals to 2, x plus 2 squared plus 6. Try this. Use the method I showed you just now. Pause the video for a while and do it. Here you can see that this is a concave arc shape, and therefore the turning point is actually a minimum and is minus 2 and plus 6. So therefore let's go for the minimum of x, which is f minus 3, 2 minus 3 plus 2 square plus 6. So therefore that's 2 times, that's minus 1 square, 2 plus 6 is 8. F of 8 is actually 2, 8 plus 2 square plus 6. 8 plus 2 is 10, 10 square is 100, 2 times 100 is 200, 200 is 206. Again, do a quick sketch. You know that turning point is minimum. Let's say this is minus 2 and 6 here. Minus 2, 6. Wow. Again, I've selected a parabola which has no x-intercept. So therefore, let's have a look at the domain. The domain is from minus 3. Let's call this point minus 3. And this point is 8. Alright? So you know the range actually goes, the range goes from the minimum point up to here, which is 206. Therefore, we know the range of function of x is fx is an element of real number, and it's this point here, which is 6. It's function of x to 206. Alright, so this is the